Hey there, everyone. My name is Ryan Schul. Welcome to my data science channel. Thanks for tuning in today. So, today I want to show you how to analyze Zillow house prices for potential flipping opportunities. Okay, so what is a house flip? It's when you buy a house, you try to buy low, you sell high. You're going to have to put in some sweat equity and renovate that at least a little bit, right? The housing market is going to be very efficient. You don't just buy low today and sell high next week and you make a profit. Usually you have to invest some time to do some type of renovation work and fix it up. And if you're good with that kind of stuff, then potentially you can make a lot of money, right? I'm not really like kind of handyman so much, so I probably wouldn't be interested in that kind of thing. But I've seen people do this, and they make a nice return by doing it. Okay, so we're going to look at a lot of Zillow information, things like price per square foot, days on the market, number of beds, baths, and square feet of the home, neighborhood, zip code, price history, and things like this. Okay, so I think it's going to be very interesting and a very compelling teaching lesson here. So one thing that I want to bring to your attention is this website that I just stumbled on very recently. This has all kinds of amazing data. I have to dig into this thing a little bit. Like I haven't even used it very much at all. That was my data pull that I did a couple days ago. So with this, you have access to all kinds of API data. So if I go over here, go to the Roots landing page. So Rapid API marketplace and market strategy. Let's see what they have. Resources, pricing. So you can go through these tabs over here. The pricing for this tool, it is not free, but I think you can have a free trial. I did create a trial and asked for my credit card, but it didn't bill me for anything. And I only did like a few data polls. It wasn't like massive information, but I wanted to show you this if I could find it. Public marketplace, industries, resource. Maybe this was it over here. Resource, contact. Oh, I'm not even signed in. I think that's what the problem is. Okay, so they just have the main landing page over there. Okay, now I am signed in. So if you go over here on the left, you have all these different categories of data that you can pull from their API list, right? So 1,077 just for cybersecurity APIs. That's pretty extensive, I think. Over 1,000 cryptography, movies, jobs. 172 related to movies. I see jobs. I see energy. So 100 for jobs. Okay, that sounds pretty interesting. I might have to check that out. Energy monitoring, 63, only 63, so not quite as many. But then if you want to search for another API, Zillow, it's going to show you all the Zillow data. So they have a bunch of them here, 1, 2, 3, 4, 5, I guess 5 or so. And then you click on the API, and then you have all the details about the API endpoint, right? Here's your curl request. And this is what the Java would look like. Not Java, the JSON would look like, right? So you have all your parameters there. So that's why I started to poke around on that site. I just created an account. I looked into getting Zillow data straight from Zillow, and you can do some screen scraping. But based on what I found, you couldn't actually access their API, or they made it very difficult to do so. I don't know why that is, but it seems like it's not very feasible to access the Zillow API, or certainly not easy, but I found it through this website over here. So you might want to check that out, right? At rapidapi.com, create an account, and then you can pull in your data. So that's exactly what I did here. Here's the JSON formatted data, right? So that's what comes in. And then once you get that, you can clean it up into a data frame, so it's a little bit more useful and easier for a person to read. So I hit Control Enter on that, and I can see address, price, bedroom, bathroom, living square footage area, living area, square foot, lot size, lot area unit, and so on and so forth. Price change, days on Zillow. So I see 19.1. That one just came out. This one looks like it's maybe gone or something. It's missing some data. And then you have this over here, Zillow estimate. So that's for renting. Rent estimate. Is that 1.79? That seems a little bit. No, I thought it was 50,000. Yeah, 5,000. Okay, so you can rent that for 5,000 per month. This is 3,400, right? And over here, you'll have a URL where you can click in it, and it's going to take you to to like whatever it takes you to over there. Now you have these things right here. So that looks good. I think just quick sanity check. I think this makes sense. I'm going to delete that. I was testing that idea. I didn't like it, so I'm not going to use that. So the first thing I'm going to do is a little EDA analysis. EDA is exploratory data analysis. And we just print out some basic charts and graphs just to understand basically what is the data saying to us? What's the story here? So here's a distribution of prices and the counts of each one. So I have 16 houses that are selling for between 0 and 1 million. I have 12 that are between 1 million and 2 million, and so on and so forth. Now we're getting a little more expensive, 3 to 4 million over here. You have this guy over here that's almost 12 million. That's an outlier. This is definitely an anomaly, but it's probably a huge house, right? I mean, I don't think that's a mistake. I think that's real. And this one is 30 million. Yeah, so that's a little bit chunk of change right there, but that's okay. So we know that we have like 3 outliers, and most of the data is pretty normal between 1 million or so and up to 4 million. That's what I'm seeing there. So here we can create a scatter graph. I'll hit Control Enter to refresh it, and you can see the same concentration on here. When I zoom in, you can see all these houses over here conform to exactly what we saw up above, right? And it's a little hard to read. So this is 1.0249 million, 3-bedroom. Square footage is 1656. Zoom out, and then you'll see some outliers over here. That's the first one that we saw above, right? So that's a huge house, right? Almost 6,000 square feet of living space. That's a lot of house. I see one over here. That's pretty big. That guy's asking almost 30 million, 7-bedroom, I mean. And this one is 11 million with 7 bedrooms. Okay, so that's EDA. That's how you can see the distribution of data. This I like because you can see everything plotted on a regular map, and you can see where these houses are located across the city of Boulder, Colorado. Okay, so there's that one that we just saw, 11.7, 7 bedrooms. So that is this guy right here, I think, right? Is that one? Yeah, 11.7, 7 bedrooms. So you can just see visually here what it looks like on the map. I didn't like this style of map. This is called a map box style. So they have a bunch you can pick from. I tried this one over here, OpenStreetMap, and when you run it, I think it's a little bit more natural looking. Let me see. Something happened here. What's going on? Oh, custom 0 is not in there. Okay. Custom 0. I don't think I need that. Let me get rid of that one. And a comma. Okay, so now we're back on track here. So I think this is a little bit more interactive and pretty nice to play around with. You can zoom in. You have a zoom control over here. All right, so you can zoom in. You can see all the details of the streets. I think it's very cool. I like this feature a lot. And then zoom out, of course. You can see where all the houses are plotted here relative to like the local shopping center and the banks and whatever you have to do there, recreation facilities and things like this. So those are really nice. So that's just basic EDA, right? Exploratory data analysis. How can we understand the data set and interact with it a little bit? Now I want to go ahead and train and test a model and ask it to make predictions for me about what should be the cost of a house given the features that we trained it on. So we have bedroom, bathroom, living area and square feet, lot area, and then price. And we already know historically what all the prices are. We know based on the number of bedrooms, bathrooms, usually bigger is more expensive, right? A larger house corresponds to a more expensive house. Not always, there's exceptions, but that's pretty much the case here. And, you know, I really wish that we did have a little bit more data. All we're getting is this right here. So we have the address, prices, bed, bath, living area. If they gave us a lot more features, we could use more features and train the model and make more accurate predictions. I think the model is performing okay. I'll show you just in a minute why that is. But the number of features that you're training and testing on is kind of limited. You only have 4 independent variables, 1, 2, 3, and 4, and you're trying to make a prediction on a target variable. And if you see my other videos, I go into a lot of details about the machine learning. This is a random forest regressor. There's many ways to do this. I'm not going to get into all the different machine learning data science techniques here because this is more about analyzing Zillow data and doing house flipping. But I would invite you to check out those other videos and learn about it because this stuff is super cool, right? Like I said, the model is making good predictions. It's about 83% accurate. We have a root mean square error of 1.3 685. So it seems like a big number. And when you square that, you get 2, what is this, trillion? There's million, billion, you get over 2 trillion. So that's a big number, right? It's just a square of the RMSE. And this is coming in pretty big because we have these big deviations, right? We have 3 outliers that are really throwing us off here. We have this $30 million guy, this at 14, and this at almost 12. So if those 3 didn't exist, the R squared would probably be pretty close, but be about the same. But this number would be way lower, and this number would be way lower too. Essentially, it's just saying we're averaging all the squares differences between the actual and the predicted value. And because we have 3 outliers, it's kind of throwing things off a little bit here. But that's fine. It is what it is. We could actually kick out those 3 outliers and redo the analysis. But I think it's important to leave those in there too, because it helps with the richness. And let's say you have a house that's coming up for sale for 7 or 8 million. That's going to be a big house. That's going to be an outlier. But you want to capture that data too. If you kick those out and you're looking to do some house flipping and a big opportunity comes along like 5 or 6 million, the model just is not going to know what to do because it wasn't trained and tested on that type of pricing point, right? So here, the model has been trained and tested. Now we can put in variables. We can say, if we have a 2-bedroom that comes up and a 2-bathroom and has living area of 3,000 square feet, I'll change it to 2,000. And the lot area is 2,000 square feet. We can predict a fair price of the house, $769,360. Now that's where it gets very interesting. If you're a house flipper and you can get it for less, this should be the fair market value of the price. You might have an investment opportunity if you can pick that up for $700K. And it's been on the market for a while, but the fair market value is $770. You could probably turn that around pretty quick and sell it for $770. Now that's just like the statistics and the mathematics behind it. It doesn't necessarily work like that, right? If the market has been on the house, not if the market has been on the house, if the house has been on the market for a while and nobody can sell it at $770 and that's the fair price, then are you going to be able to sell it for $770K? Probably not, right? There's probably a reason. Maybe people just aren't active in the market right now. Maybe a lot of people came to look at it and they just didn't like the style, or the interior was old, never renovated. Who knows? There could be a bunch of things. So I'm just saying, if this is a fair market price and you can get for less, you probably have a good opportunity to generate a profit, but there's certainly no guarantee about that, okay? And again, let's just change the variables. Let's say the inside and outside is bigger. Now we have 5,000 square foot lot. Living space is 3,000, and we have a 4-bedroom and a 4-bathroom. So in the last example, 769. Now more house, more lot. You have a house that's worth 1.065 million, right? And you change these variables a little bit more. If you have a pretty large inside house, I would expect this to jump up a little bit. Instead of 1.065, we're looking at about 2.5, okay? So that's substantially larger. It's 5,000 square foot versus, what was that before? It's 3,000 square foot or something? Yeah, I think that was at 3,000 square foot. Okay, so you can see how the model has been trained and tested, and you can make predictions. I'm doing exactly the same thing down here. The format is just a little bit different. Everything is contained in this print action right down here, right? Instead of interacting with the model like this, we're just putting everything into variables that are being passed over here. So this house is about 1.36 million. If the conditions were a little bit different, 3-bedroom, 3-bathroom, 3,000 square foot, and we'll say the lot size is 8,000, I can basically guarantee you it's going to be less than 1.34364. Control Enter, 1.076. Okay, so the variables change, the input changes, and the output changes too. Again, trained, tested the model. Now we're using it to make predictions. That's what we're doing here, right? So now, because this is all static data, there's no time series whatsoever. It's just what's happening in the market right now. There's no change in time. Like, okay, I can see price change 0, 0. This price was decreased. I can't see how long this house, wait, they should show you, days on the market. Yeah, they do show you days on the market. But historically, you can't see what this house sold for or what was the intrinsic value of this style of house a couple of years ago or several years ago, right? So it's really a point in time. This is PIT data, point in time. But if you do want to look at a time series change over time, you can get actual data from Zillow. I got that from, let me see, where's the source over here? I have a link to that. Yeah, okay. So Zillow is nice enough to include this for us, even though they don't give us access to the API. Again, as far as I know, maybe there's something out there. I didn't see it. Now you have home rentals, home forecast. Wait, which one is this? I think I picked on time series. And the data type rentals, download. Home values. I think this is the one I got. I have to look at my notes, but there's only a few buttons on here. If it's not one of these, it's the other. It's probably 9 or 10. I think I picked the first one. So when you download that, you essentially get this right here, which has region ID, region name, okay, city, state, and state name and state abbreviation. Looks like this is duplicated. I don't think we need two. They're exactly the same, but okay, that's what they're giving us. Then we have metro area, county name. And then this is what I like. So this is the time series going back to the end of January 2000 up into last month. Well, now we're into April. Okay, so they cut it off. It probably takes several days, maybe a couple of weeks to generate the data. So March will be coming out pretty soon. I'm guessing this is the beginning of April, so we certainly won't have April data. But this is nice because it goes back about 25 years, just over 25 years, and you have all the changing and house prices over that time for the entire United States. So that's pretty cool. That's where I got my time series data. Then we can do time series analysis to see the change in home prices by region over a period of time. So let me go ahead and run this. This is using Facebook Profit. This is a very nice forecasting tool. Now it doesn't have that. Oh, I think I didn't import this. Let me import this. Okay, import the data. And I see that right there. No Plotly installed. Okay, weird. Plotly is not defined. Plotly. Let me look at this error. This is a new one. I was playing around with a couple things earlier, so maybe I deleted something that I shouldn't have deleted. But let me see. Okay, I'll look it up. We'll try to fix this thing. Because all this was working. Oh, okay. Fig that show. Okay, and then we'll see the time series plot changing over time. Now, again, I'm just looking at one item on here. Oops, we got another error. Region ID, size, rank, region name, region type. Oh, no, it should be in there. Let me try it again. Okay, that should do it. Unless it was another intermediate step I just cut out. Okay, and that. Oh yes, I think we're changing the format of the data too when it comes in. Okay, that should work. I think. Let me try this again. I'm good at working. Don't worry. And then this. Okay. And then, yay, we got it. Okay, so there was a couple things. I was fiddling with the data, and then I deleted something that I shouldn't have. So what I'm doing here is looking at the region name Boulder and then the state of Colorado. So I have Boulder in a couple of my videos, analyzing some other things. I've been there a couple times on trips, and I just love the area. It's very nice. It's very kind of smallish sized city. Maybe it could be an intermediate or mid-sized city. I think it's kind of leans towards smaller, but very beautiful. Very scenic, gorgeous mountains and streams and rivers and everything. It's a very idyllic community. That's why I picked this one. And because it kind of is smaller, maybe mid-sized, but it's not as massive as like a New York City or Chicago or LA. So it's easier, I think, to do these types of analysis. If you're looking at a huge market, then it would just take a heck of a lot more work. Now you can use the same, like the same concept and change out Boulder for a different city name and then change your state to a different state name. I think for education purposes and starting here, I think it's just easier to work with something that's smaller and then build up as you go over time when you get more comfortable. If you start with the New York City and you're starting to do analysis on that, and you're trying to learn all this stuff at the same time, you've really got your work cut out for you. I think just start small, make that work, and then scale up. That's what we're trying to do. So this plotly is essentially plotting the time series change in housing prices in Boulder over the last 25 years. Okay, so you have these nice little sliders, which is kind of nice. You can zoom in. This over here was during COVID times, right? So you saw housing prices jump up and they really spiked quite a bit. And then it came down a little bit afterwards and it's kind of settling down. So the darker line shows you the overall trend, and then you'll have an outlier on the top and an outlier on the bottom. Okay, just to show you basically within that range or that threshold, how these stock prices, how these home prices are moving. Okay, so you'll always have an upper or lower band, and then the blue line, the dark blue line, will show you like the average predicted price. Here you can see the same trend down here, and here you actually see a very interesting seasonal pattern. So in early February, prices spike up quite a bit, and then they dip down, and that is pretty consistent over the last 25 years. So you have this big price. So if I was a market for a house in Boulder, I wouldn't be looking in February or early March. I would wait for things to calm down. And activity is a little less volatile. It's a lot less volatile once you get down here later in the year. Okay, so there's some seasonality effects over there. So let's go ahead and do the analysis. Now, we can add new features like momentum, which is price change divided by days on Zillow, and add that as a feature to train the model on, okay? Or just use it to help us understand, is this a good opportunity to flip the house or not flip it, right? So if it's been on Zillow for a number of days and this inventory is just not moving, then I want to know about that. I want to understand why and figure out what's driving this momentum, or if the house sells very quick, why is that happening too, right? So we don't really have the information in this data to answer those types of questions, the why something happens. That would be more like causal inference. I have a couple of videos on causal inference if you want to take a look at that. That is why things happen, okay? And there's always a cause and there's an effect, and causal inference will help you understand that. I'm not doing that kind of analysis right here. That's really a different approach. So we have the price change divided by days on Zillow, and then we have that's called momentum. Okay, so that's how we're getting our momentum number over here. Okay, and you can see here's some negative momentum. I think they had the price drop. Yeah, price change negative, and days on Zillow was just 6. So not sure why they dropped the price. $349,000. 350, 3.5 million. It's a 10%, about a 10% drop. Well, why after 6 days? I don't know. That sounds a little bit weird. But you can see the momentum over here. So this one has a little bit negative momentum, and that's what you're looking for too, right? If you want to get a deal, if you're a house flipper, you want to see this kind of activity. I mean, I just think 6 is like too short for them to have a price drop of 300. Am I reading that right? 300 million. Maybe they made a mistake with the listing, but that sounds weird too. I don't know why. I don't know why they have that. That is a little bit weird. Okay, let me refresh the view. I think something got pushed out of the memory here because I didn't see the last part of that analysis. So let me go back here. Okay, so we saw all this. That is good. We're making predictions. There's a time series using profit. Oh, now we have our momentum. Okay, that's good. Now we can predict and rank homes by value. So this is bang for the buck. So again, these are the variables we're looking at. I wish there's more. There's just not any more than this. Usually more is better, but we can still use what we have. We have living area, lot area, bedroom, bathroom, and then price. Right, and based on this, we are going to try to predict fair market value. Okay, and we're going to use that regressor that we trained above. So if I can do Control F and look for this, it's highlighted orange, right? So that's very convenient. Thank you for drawing my attention to that. Go back here to regressor. Remember, this is the model that we trained and tested before. So we have a random forest regressor. We fit the model right there and then made the first prediction right there and the second prediction right there. So that's where this regressor is coming from, okay? So it is backed up by math and stats. I'm not just saying, oh, here's simple momentum or moving average or something. We trained the model, tested it. Now we're using it to make predictions about the value delta. Okay, and this comes from the predicted value minus the Zestimate value. So this value comes from Zillow. Sounds like estimate. It's called Zestimate. I guess that's kind of cute, right? So this is their estimated value of what the house should be, and we're making our own predicted value and then taking the difference. So we're comparing those. Okay, so this is pretty cool. So we have the regressor looking for the delta between predicted value and Zestimate. That's a kind of a cool name. I like it. And then we have this over here, and that comes under value data. I'm not seeing that here though. Where is it? Oh, here. So predicted value minus Zestimate. So if this is lower, if this is lower, this will be negative, right? This will be negative note over here. And if this is higher, this would be positive. That makes sense. So if this is 2 minus 1, this will be positive. If this is 1 minus 2, this will be negative. So let's see what our predicted value is. Predicted value 299,229,138, and they say over here 349 mil, and the estimate, the Zestimate, I love that word, Zestimate, 338. So there's Zillow's saying it's a little bit less, pretty close though, pretty close. And our model is predicting even less, 229,000. So that kind of is a big delta there, because they're asking 3.4 mil, 3.5 mil, and our model is coming up with 229. But remember, we only had about 5 different features that we're training and testing, and the accuracy of the model was about, what was it, 83%, right? Let me go back and double check this. About 83% of the time it's making accurate predictions. So 17% of the time it's not not accurate, okay? So this is really where the rubber meets the road, and this is where you have to do your due diligence, okay? And say, is a house actually fair market value really close to 230 million, 2.3 million, which is what our model is predicting, or is the actual fair market value much higher, 3.5 million over here, right? Or these sellers just greedy and asking just way too much for the house, right? But the Zestimate is coming in lower. Our model is predicting lower. So it's very interesting. This could be a fantastic investment opportunity to do a house flip, and you could make a lot of money with it. But again, there's no guarantee with these things, and there's a lot of variables to consider, okay? But essentially, that's how it works. We're using a regressor to get trained and tested and make these predictions, and we can compare that to the actual asking price and then the Zillow estimate, or the Zestimate. I like that name, Zestimate. Okay, I was going to look at one more. And these, I think they don't have an estimate, right? Because if I'm looking over here, this is 0. So yeah, when you have zeros over here, it's not quite as useful because we just don't have any values for comparison purposes. So, to have more data and to have all this data filled in would be much more useful. If you're just missing values, then it's going to be kind of hard to do a really fantastic analysis, right? Like garbage in, garbage out. We're missing all the Zestimate numbers down here. So you're kind of handicapped a little bit there. But this one looks pretty close, 249,000, 2.36 million. And this is coming in a little bit low, 220, but low, but pretty close, right? 2.2 million is what we would offer this person. They're asking 2.5. So it's like a 30,000 difference, right? And the difference with the model and the estimate is 15,000. So then it's really up to you as the potential house flipper. Are you going to come in with that offer? It's a little bit low, but these guys might take it. Look, it's pretty close to their actual asking. If you offer this guy over here, he's asking 3.5 mil, and you come in and offer him 2.3, yeah, he might just laugh at you because that's over $1 million less than they're asking for. I don't think they're going to go for that, but I mean, you could at least start the negotiation process at that point. So Key components, overall look at trends, yearly seasonality, we saw that, weekly seasonality, holiday effects. I think this over here is more seasonal. I don't think it's a holiday effect because you're after Christmas, you're after New Year's. I think that is some kind of just seasonality change over here, but it is nice that the model captures that and that it shows that, because that stuff is interesting to know. So one more thing is I'll just say be careful. There was a problem with Zillow a couple of years ago. I have the webpage down here. You probably saw this in the news. They lost $880 million by flipping houses themselves, right? So Zillow got into the house flipping business, lost 881 million, and you can read through the article. I'm not going to read it all for you, but basically the model was making a lot of predictions about house prices, and the takeaway was the model was right a lot of times, but it tended to overestimate the value of these houses, and it would not really underestimate the value of houses. So the problem was people at Zillow came in and bought all these houses. They didn't really question the legitimacy of the model. I think they trained it and tested it. They were pretty confident. I think what happened here, they were just looking at this. The model says do this, so we should do this. But you have to use good judgment too. If the model tells you to do something, okay, that's great, but that's just a first step. You really have to understand exactly what's going on. And the takeaway, I think, was the model was overestimating, making people offers that were too high for the house, right? And some people got excited by this and just said, okay, I would take the offer because it's a sweetheart deal. It's a lot of money. Let's get out of here. So they would overpay for one house, but you would expect them, Zillow would have an offset by underpaying for another house. But the problem was, if you offer too little for the house, the people would just say, no, I'm not going to play this game. Get out of here, right? So almost every house that they bought at the fair market value, or they overpaid for the house. They didn't get any deals or discounts because people simply said no if the model came in with a lowball offer. So it's a fascinating story. You can read about that. So the whole point is, okay, we have a nicely trained model. It runs, it works pretty well, 83% confident. And there's ways that we could probably boost it. This video is not about boosting the performance of models, but there's ways that you can fine and tune the model and add in new features. I've got other videos about that. If I added in all that stuff, this video would drag on for several hours. I'm already 32 minutes into it. So yeah, I'm not going to get into that. But there's ways to probably boost the performance. I know for a fact you can boost the performance of this and get it more accurate. But again, I think it's a very quick and dirty way to estimate the value of houses in whatever market you choose. Again, I'm focusing on Boulder, Colorado. I like that area. But you can choose any kind of city that you want, any type of region of the United States. You have all the data you need. Okay, so that's it, guys. I'm going to wrap it up. Thanks for your time today, and I will see you in the next video. Goodbye.